Hey everybody, this is the third of the supplements here for Chapter 2, and this one is Structure Theorem. This kind of dovetails with the very first part of Chapter 2, which is the 6 basic computer operations. Everything, again, within all of that wonderful magic it is that the applications and the processes we use, it appears to us like there must be this tremendous array of functionality that is extended to computers and systems and applications and processes. But at the end of the day, that's just not true. Whether or not we are looking at, the most basic application someplace, something like a calculator is really dead simple. Or if we're looking at something that is globally spanning in its architecture, something like a project management system or a system management system. So that's actually a piece of software that is built to manage other huge pieces of software. All of that is really relying on one of 3 basic control structures. And really, I do mean this. This is very much like in The Wizard of Oz, looking behind the curtain and finding that Oz the Great and Powerful is just another one of the Oompa Loompas. When you look at all of the tremendous and complicated software it is that you can be a piece and parcel of, when you look at all the tremendous processes that you can be a part of the parcel of, we can really break all of those interactions down into one of 3 kinds of control structures, and that is insane. The first of these we can see here on page 15 is what is known as sequence. Sequence gives you a concrete order from 1 to however many you need, and the order of operations has to be followed exactly the way it is that it is algorithmically designed in your code, or here for us in your pseudocode. Next comes selection. That is where we are presenting the algorithm with a condition, a value. And that value will trigger the choice between one of a certain amount of actions. So we would say things like, if student is alive, continue to breathe. Else student is dead, drive stake through heart. We have an if statement, an else statement, and based on the condition, is the student alive, true or false? We are presenting algorithmically a set of instructions based on true, and we are presenting algorithmically a set of instructions based on false. So that is selection. You are literally making a choice. So we have sequence, A, B, C, D. We have selection, one or the other. And finally, we have repetition. This would be represented, again, with the do while or any of the other loops it is that we'll see in chapters 4 and 5. A repetition control structure essentially provides your algorithm with a way to repeat itself, either a set number of times or a conditionally set number of times. So I can say do while count is less than 10. So that is a hardwired count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I can say things like do while more students exist. There may be 1 student, there actually may be 0 students, there may be 1,000 students, but that particular repetition is going to just keep going as long as that condition is true. And all programming can be broken down into sequence, selection, and repetition. The simple calculator program: sequence, selection, and repetition. Your large, globally scaled, multinational system operating system: sequence, selection, and repetition, and everything else in between follows exactly one of, or any mixture of, those 3 kinds of basic control structures. Those 3 basic control structures, sequence, selection, and repetition, we call structure theorem. It's how We look at every application. It's how we look at every process that we're going to design is here with the lens of structure theorem.